Okay, so I put feedback out there, and I was trying to be helpful, but not overly helpful, because the goal is for you to go back and revisit them. So if you look back on the last slides, there should be space on each slide, like slides like think 14 through 23. They're basically a repeat of your answers, so you can see like what the feedback was, and make revisions to your thinking. And then I will grade it based on the overall, like, how you did as a whole. So if you're able to, convince me that, oh, I totally see what I got wrong and I'm so much better, that will help your cause a lot. So if you just go in and make changes and you give really skimpy, like, reasons for them, then that won't be as convincing and you won't recover as many points. And some people did perfect jobs, so, you might not have to do anything, and this might not apply to you. All right, second thing I want to say, a couple of little things. Let's see. Let me see if I can demonstrate something here. If you were typing in a box, like, am I not sharing? I'm not sharing. Give me a second. Okay. If you want to type in a box that is a text box, but you want to type an equation, or you want to type math, if you come click on this, I know it looks like a square, it is a square root symbol, a radical, but that doesn't mean you necessarily have to do the square root of something. It just says you want to type math. So if you click on that, then you can type math. So if I want to type my answer is, and then all of a sudden I want to type like e to the 2.5t, and then you can alternate between like math and regular text. So I saw people are having really trying hard to format their answers in the box. So just anytime you want to click math, type something in math format, click on that, and that's helpful. The other thing is too, a lot of people did their math in the actual calculator, which was very helpful to me to help you, because I would see people have perfect things written on their screens, and then then they would have the wrong answer, like in the box, and then I would click on what their calculator said, and I could diagnose, like, oh, you forgot the negative, or you didn't close your parentheses, or something simple that I was able to help you, that you might have thought, oh my gosh, I thought I knew what I was doing and I got it all wrong, and you really did know what you were doing. So I'm going to encourage you to use that. But anyway, okay. So that was Monday, and if you can make your revisions by Sunday, that will be great. So Tuesday, Wednesday, you're supposed to do some SOHCAHTOA review. And again, if you're struggling or unsure or uncomfortable with like your SOHCAHTOA skills, reach out to me, and tomorrow I am available like almost the whole entire day to help with SOHCAHTOA if you need it. Okay. Today, what I'm going to do is I'm going to start us on screen 10, because screen 10, 11, 12, and 13 are like the new content, and that way we will all go over that together, and then people that understand and or feel good about SOHCAHTOA don't have to hang around. And then the first screens up through screen 9 are about SOHCAHTOA type of things, right triangle trig, I should say. So right triangle trigonometry. And if you have questions about right triangle trigonometry, then you can hang back with me. Right. Okay. I'm talking too much, but I want to sort of get through this, as it's the end of the week here. I believe that everyone right now should have some paper and pencil to take some notes. And you would want to start on a brand spanking new clean page, and you want to label that page Intro to the Unit Circle. And you want to draw this lovely picture. Okay, so you do not necessarily have to even be in this Desmos activity right now, because each of these problems, we're only doing 4 screens. You can just hang out on my teams, on our teams tab, and do the problems together with us, in your notebook, and then just go back later and quickly fill it in here. It's up to you, but it might be too much to try to write stuff in your notebook and toggle back and forth between the different tabs. Okay, so let's talk about Intro to the Unit Circle. Okay, so the main reason that the unit circle is called the unit circle is because the radius is 1. Okay, so it's like one single unit. People walking by don't want to be. Okay, all right. The center of the circle is at 0, 0. So here's your x and your y and your x-axis. The center is at 0, 0, and the radius is 1. Okay? All right, so we can make all kinds of angles inside of here, but we say that the angles obviously have two sides, an initial side and a terminal side, right? The initial side is always this positive x-axis. This is where the angle initiates or starts. So it's called the initial side, and then like you know, around, and wherever you end is called the terminal side, or the like where it terminates. So this angle starting right here and ending wherever the heck it ends, it's called an angle of rotation. And it always goes in this direction. It always starts at the same spot. Okay, and I'm doing my best. I found that I actually write better in cursive, which maybe that's 12 years of Catholic schooling. I don't know. But on my other class, I wrote angle of rot, and then like someone's like, "What's the angle of rot again?" No, don't call it that. Don't call it that. It's an angle of rotation. I ran out of room. All right, so it's called an angle of rotation. Okay, so the angle of rotation, it could be anywhere on this circle, anywhere. So, okay. So what I want us to do now, you have this lovely, thing drawn on your notes. Hopefully, it's big enough. It doesn't have to be like the whole page, but you don't want some like microscopic thing because we're going to start labeling a few things on here that are really super foundational and they need to make sense. So again, a first thing we're going to do is we're going to label some angles on here. Okay, so if we're at the starting point, we're going to say we've rotated 0 degrees. If let's say our terminal side was right on top of our initial side and we haven't rotated at all, then we'd be at 0 degree angle of rotation. Okay, what if we rotated all the way up to the top? Normally it's like, what do you think? But let's just get through this. I think that everybody see that would be a 90 degree angle of rotation, right? If I went from the farthest right to the tippy top, that would be a 90 degree angle of rotation. And then if I continue around the circle counterclockwise, and I got halfway around the circle, 180 degree angle of rotation. What if my terminal side was all the way down here at the bottom? Maybe 270 degrees, okay? 270 degree angle of rotation. And then finally, if we ended all the way around, like we went all the way around, came back to where we started, we'd be at 360. And I think probably everybody knows that the circle has 360, or if you didn't remember, you heard it once upon a time, right? It was like most people knew that like half a circle or a straight line would be 180 degrees. Okay, so these locations on the unit circle, they need to get to at some point where if I say 90 degrees, you're picturing top of the circle. I say 180, you're picturing far left. 270s at the bottom. Like you will know that really quite quickly because we'll use these as benchmarks on the unit circle quite a bit. Okay, today's goal, our goal for today, is that we can find the coordinates for any point on this unit circle. So like this point where this angle of rotation ended, I want to know the coordinates of that point. So our goal is to find a strategy to do that. All right. So let's start with the 4 points that we already have, that 0, 90, 180, 270. Let's find the coordinates of those. So those we don't necessarily have to find. We can read them right off the graph. Okay. The fact that our radius is 1, and we know that this point in the middle is 0, 0, then if I'm at 0 degrees, like if I'm looking at this point on the circle where we started, that point would have the coordinates 1, 0. Normally, I would ask everybody just to fill out that you'd have a piece of paper in front of you. You'd be like filling this out yourself. But, you know, here we are in virtual land, so I'm sorry I'm talking at you so much, but I really do want you to be writing this like in your notebook. Is this that foundational? Okay, so if we're at the top of the circle, where would the coordinates be there? So if this is 0, 0, and we're going up 1, but we didn't go left or right, so that would be 0, 1. Okay, and then you can probably figure out what the other two are going to be. Like if I go backwards, but I don't go up or down. So this is going to be negative 1, 0. And, you know, I have to write within my circle because I ran out of room, but you don't have to write it inside the circle like that. And then if I'm at 270, I went down 1, but I didn't go left or right. So right, our x is going to be 0 because I didn't move left or right, but my y is going to be negative 1 because it moved down 1. All right, so those 4 points are pretty, you know, readily found right off the graph because the radius is 1. But if the radius is 1, this distance is 1, then, you know, then this terminal side is always going to be 1 too. So how can we use that to find the coordinates of any other point on the circle? So I'm going to move us on to screen 11, and you can just stay with me if you want. But this is this nice little logical, hopefully, connection to what we have been learning. All right, let's see. Let's look at this. These graphs, which Miss Wanche made in GeoGebra, just by the way. Okay. So we would say, like I would say, angle C is, point C is at an angle of rotation of 50 degrees. Like I want to just sort of use this vocabulary. It's at an angle of rotation of 50 degrees. So it went from here to here. It's 50 degrees. So this angle, when we use the angle of rotation, it's always the central angle, like at, you know, the angle at the origin. So how can we figure out what point C's coordinates are? Okay. So, well, what do you think about when you have coordinates? You want to know, well, how far over or up did it go? So I drew this lines in. Isn't this going to be his x coordinate here? How far over? How far over did he go? And then this will be his y coordinate. How far up did he go? And lucky for us, that's a right triangle. And we know this angle here, the central angle is 50, our angle of rotation. And the last thing that we know is that this is a unit circle, so our radius is 1. So take a moment, see if you have an idea of how could we figure out what the values of x and y are based on, you know, what we've been doing. Any strategies? Anybody want to blurt anything out?
You can do sine of C.
Say that again, I'm sorry.
You can do sine of C.
Sine, okay, so we can do the sine, right? We can use sine. What would sine help us find?
X.
Okay, so what? Oh, sine of angle C. I see what you're saying. I see what you're saying. C, you said C. I said, I'm going to erase this. Hold on. Okay. All right. So that's Cameron talking. Cameron, that will absolutely work. We could use the sine of angle C and find X. I feel like, let me get back here. All right, if I'm using using crackers. If I'm using angle C up here, then X would be opposite, and we have hypotenuse. But there's nothing mathematically incorrect with doing that, and I don't want to make it sound like I'm rejecting your idea. I'm going to encourage us to use this angle of rotation of 50, though. This is this angle here. This is 50. And I'll tell you why. The main reason why is that a pattern's going to start to emerge, and then the pattern will be useful. But you would get the same answer if you used angle C. So what if we want to use this angle, this 50-degree angle that's provided to us? Have any thoughts about how that could help us find X and Y? Could we use sine there too? What if I was using sine? What would I find? Like, what would that help me find? Us find? Okay, so
Side,
Cameron, say it again. I'm sorry.
side Y.
Side Y. Okay, thank you. All right, so I want to make sure everybody's got to be with us right now. Like, I hope you're not just logged in and like watching Netflix or something. All right, so if we use the sine of this angle, and the angle's 50. So if I say sine of 50, and you can, you know, sketch this real quickly in your notebook. Don't make an art project out of it. X, Y, draw a line. It's like approximately 50 degrees, right? Okay, so sine of 50, we know sine is opposite over hypotenuse. So opposite is y, and hypotenuse is 1. All right, this is great. The hypotenuse is 1. That is so nice. Like, I don't know what's the better word for that. It's so handy. Like, what's y divided by 1 is just y. So, right, y over 1 makes that calculation easy. So I can just say y is going to be the sine of 50. So I'm just going to come in here, type sine of 50. All right, it's 0.766. So this is 0.766. All right, what if I wanted to find x? So x is adjacent to this angle, so we could use cosine. And again, like that's why we spent 2 days reviewing because the relationship between sine and cosine, tangent will come in too, but not as much as sine and cosine. Sine and cosine are very instrumental in the unit circle. Cosine is going to be adjacent, which is x, over hypotenuse, and the hypotenuse is 1 again. So x is just going to be the cosine of 50. All right, so it's going to be 0.643. I'm going to round it to 3 decimal places. 0.643. So the sides of the triangles represent the coordinates of point C. Are you making that connection? I hate that I'm making that connection for you, or maybe you were making that connection on your own, but I need that connection to like sink in. Like, oh, this is how far over, this is how far up. That's just the side lengths of the triangle. So if we use right triangle trig, we can get the side lengths of the triangle. So like Cameron pointed out in the other class, somebody else was saying, well, I'll just use Pythagorean theorem to get the other side. It's like, yeah, you could do that. But I'm really trying to drive home this like relationship that if this is my angle of rotation here, you know, in the middle, the x is always going to be adjacent to that angle. And y is always going to be opposite that angle. So we can associate x like with cosine. And we start to associate y with sine. That association will get stronger and stronger and stronger as we continue on into this unit. All right, so I chose to draw that line in there to make the triangle. So if you were given a circle like the one on the right, you can see that line's not drawn. But you can say to yourself, well, if I want to find the coordinates of point C, I can just make myself a handy dandy right triangle. And I know the hypotenuse is 1 because it's the radius of a circle, right? The radius is 1. This is 1, 1, 1. Anything from the center to any point on the circle is going to be 1. And this is your x. This is your y. All right. So just with the, you know, let the calculator do all the heavy lifting for you. So I spent a lot of sort of time on this first one just to sort of like get the ideas out there. And then hopefully in the future you're like, oh, I can do this. Then x would be the cosine because he's adjacent. And I don't want anybody like to memorize like x is cosine. I would want you to see like, yeah, well, he's adjacent, right? So of course that makes perfect sense because cosine's adjacent over hypotenuse. Hypotenuse is 1, right? y is going to be the opposite over hypotenuse. So y, over hypotenuse. Let's see. It's the sine of 30. I know what this one is, but I'm going to put it in just to tell you. And if it's, look, this one, if you want, you could change it to a fraction. Oh, that's nice. Isn't that nice? I don't care if you change it to a fraction yet, but you'll see that we'll be using fractions a lot when we come back from Thanksgiving, I guess, probably. Okay, so, all right. So now we have the coordinates, right? We know that point C is over 0.866 and it's up 0.5. It makes sense. Look, it's over almost all the way to 1. It's certainly over further than the 50-degree angle one was. So, right, and this is not up as high as that point was, so it should be, less than 0.766. All right. All right. One other, just nice little relationship that I'd like to just make sure I highlight that I think I brought up on yesterday, but maybe not, is that the bigger the angle is, the bigger the opposite side is. So this angle is 30, and that means this angle has to be 60. So 60 is going to have a bigger side opposite it than 30 would. So that sort of makes sense. Try to think that a small angle is going to have a small opposite side, and a big angle will have a big opposite side. And of course, 90 degrees is the biggest angle in the triangle. He has the biggest opposite side. All right, so that's nice. But what would happen if we go and we look at the next slide and we notice ooh, shoot, the first one looks pretty straightforward, but the second one, the angle of rotation is all the way into the second quadrant now. Okay, so again, stop me if you're like, what? But I'm hoping, that this looks just like the last two that we just did, and you're thinking, okay, I can do this. Of course, if you didn't invest energy in reviewing SOHCAHTOA, this might seem harder. Let me look at the other one. We did 50 and 30. Now we're doing 40. Okay, 40. So I can find the cosine of 40 will be this side, and the sine of 40 will be this side. So let me just do those real quick. All right, so this is 0.766 and 0.643. Those numbers seem familiar, don't they? Weren't they? I hear Kahoot music or something going on down the end of the hallway. Okay, look at these numbers: 0.766 and 0.643. I know I typed those numbers. That's 0.766 and 0.643. This is basically the same. This is the same triangle, but the sides are switched. You see that? Like Cameron was saying, we could use this angle up here earlier. This is a 40-degree angle up here, 40 degrees, because if this is 50, this has to be 40, because 50, 40, 90 adds up to 180. So this triangle is the same as this triangle. Just, I didn't do that on purpose, honestly. It's just coinciding, but right, so that 50 degrees up here instead of here. But anyway, I'm still using cosine to get my x and sine to get my y, because cosine's adjacent, x is adjacent, and y is opposite. All right, that's useful. Okay, so we have the coordinates for this point, 0.766 and 0.643. How do you think we could use this information to help us find the coordinates of point C that's on this circle on the right? So we rotated 140 degrees, and I want to know the coordinates of this point right here. Any thoughts? I'm thinking somebody has a thought. So the thought might be well, I would know how to do it if I only knew this, or if I only knew that, or are we okay with me going ahead and drawing these lines on there like that, and putting my X and my Y? What do we know about X in this case? Any thoughts about that?
I think Jada has an idea.
Oh, does she? Schoolfield?
Mm-hmm.
Okay, go ahead, girl.
So the degree of a straight line is 180, and
Okay.
if that happens 140, then the rest of this should be 40 degrees, so it all adds up to 180.
All right, so if we were in class, I'd say, come up to the board and show me what you're thinking, but is this what you were thinking?
Yeah.
So that has to be 40 there, right? And, you know, so she's saying straight line's 180. We also know, like, if, you know, right, if we had rotated all the way around to this point over here, we would have rotated 180 from our previous little sketch that we did in our notebook. So same idea, that the top half of the circle has to add up to 180. So if this is 140, this is 40. So then now we know this triangle is the exact same size as this triangle. They're congruent. They have the same hypotenuse. They have the same angle. So, you know, they have this angle. So angle, I don't know, side angle, side, I don't know what they do there, but anyway, they're congruent. Let's go with that. And so because they're congruent, then don't we already know her side lengths, right? Right. But the goal is not just to get the side lengths, it's to get the coordinates of point C. So what do you think that, you know, what's the number one thing that somebody will probably mess up on? They'll say, well, this is 0.766. That's oh my God, I'm like a serial killer writing stuff here. Okay, that's 0.766. This is 0.643. But what do we got to be careful with when we're doing the coordinates here? That our side length is actually in a negative direction. So, all right, we went backwards 0.766 and up 0.643. That says 0.643, so same triangle. Get the idea here though, but we're just totally relating our right triangle trig ratios to a circle. And the fact that the hypotenuse is 1 is why it makes the calculations just so much more easily accomplished. So just do cosine and you get your adjacent, and just do sine and you get your opposite side. But you need to know this central angle here, right? So this one became just one step more complex because, like Jada said, you needed to sort of use the 140 to get this. All right. Let's look at the last slide. So this is the 30-degree angle. I'm going to talk through it somewhat quickly. We already did 30-degree angle. We got that this was 0.866. We did this on an earlier screen. And we did that this was 0.5. Okay? So each of these that are remaining, I want you to really think about, like, how is this first triangle going to help you find these other, you know, what's the relationship between the one that we already did and the ones that we didn't do? And your goal is to figure out the coordinates of point C on each of the other remaining circles. Okay? So hopefully we're starting to, like, if I ask you, like, do you have a strategy, at least an emerging strategy? Doesn't have to be like a polished up version of a strategy, but like, I have an idea how, like, yeah, right triangles are completely related to circles. Like triangles help you find coordinates of points on circles. That's the goal. Okay, that was our number one goal. All right, if you go back to the other slides, it's like SOHCAHTOA review. So you can try those out as well. And then I'm straight up telling you right now, like, I am available all day tomorrow. If you have questions about SOHCAHTOA, if you have questions about the assessment, if you need any help whatsoever, just need to reach out to me and let me know. Like, so call it through Schoology, we can set up a Teams meeting or whatever the case may be. If anybody wants to stay now and ask some questions, that's fine too. Or if anything that, you know, anything that we just went over that's brand new, you can let me, ask your questions. I guess is what I'm saying. If you don't have questions, I'm going to tell you that you are free to go. So if you have a question, hang out, talk to us.